Assalamualaikum and good afternoon. We are honored to welcome all participants and honorable speaker to the second Smart Grid Roadshow, Smart Grid Modernizing Power System of the Future. Thank you for being here with us this afternoon. We hope the Smart Grid Roadshow become a platform for us to share information and knowledge from panel of experts for the benefit of the society. Ladies and gentlemen, grid modernization has become a catch-all phrase to refer to changes needed in the power grid to accommodate all the rapid technological changes happening in generation, transmission and distribution of electric power. In particular, grid modernization often implies the increasing application of sensors, computers and communications that is increasing the intelligence of smarts of the grid, but the main goal is still the flexibility needed to adapt to the whole range of new technologies in the grid. With this in our mind, we have invited back our special speaker to be with us today. Please allow me to introduce to you our guest speaker of this afternoon. We are so lucky again to have with us Yang Berbahagia Profesor Insinyur Dr. Muhammad Zainal Abidin Abdul Qadir, Unit and Strategy Higher Professor in Lightning and High Voltage Engineering. Moving right along, it is now my pleasure to introduce our guest speaker. Yang Berbahagia Profesor Insinyur Dr. Muhammad Zainal Abidin Abdul Qadir is a Strategic Higher Professor at the Institute of Power Engineering, IPE, Universiti Tenaga Nasional Unitan, and a Professor at the Faculty of Engineering, University Putra Malaysia. He is the Founding Director at the Centre of Electromagnetic and Lightning Protection Research, CELP, University Putra Malaysia. He is also an IEEE Power and Energy Society, PES Distinguished Lecturer in the field of lightning and high voltage engineering. To date, he has authored and co-authored over 350 journals and conference papers. His research interests include high voltage engineering, lightning protection, electromagnetic compatibility, power system transients, and renewable energy. He is also an advisory board member of the National Lightning Safety Institute and LSI USA, research advisor for the African Center for Lightning and Electromagnetic, ACLE. Ladies and gentlemen, now without further ado, it is my pleasure to invite Yang Berbahagia Prof to deliver his presentation entitled Smart Grid Modernizing Power System of the Future.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon. Thank you very much for generous introduction, especially towards this afternoon. So we're going to hear again the second talk for the second roadshow, which is again on the smart grid. So I would like to take this opportunity to thank the organizer for giving me another chance of sharing I would say the informations and also the knowledge with regards to the smart grid, at least from different perspective, as far as we consider, what will be the benefit for the nation and so on. There are several key points, and again, it's worth to note that this talk is, I would say, another extension of the previous one, which is also a brief on the smart grid. But today I would like to take this opportunity to further explain and also to further share in terms of what will be like the key changes, for example, when we talk about the smart grid worldwide, and how we're going to see Malaysia foresee, as a nation as compared to, our neighboring countries and so on. Again, from the global perspective, in terms of the energy, in terms of the demand, in terms of urbanization and so on. So as you can see, towards like 2050, for example, you can see the increment in terms of the population. So likewise, we can see the urbanization also will take place, in conjunction with that. As far as the global energy development is concerned, so you can see from the figure or from the illustrations that between 2050 and 2050, especially when we look into the potential of the solar energy, moving from just for about 1% 2015, towards roughly about 70% in 2050. So this is actually translated into the opportunity, I mean, from the business perspective, and also from, as far as for the government, to achieve whatever the target that they are actually putting in terms of the, reducing of the carbon footprint. The global and net power generating capacity as far as 2018. So you can see the distributions. I mean, say for example, solar as compared to the other renewable energy resources. So this is quite latest and also new information as far as where we are standing, at the moment. From the Malaysia perspective, again for the period of 20 years, you can see how much the in terms of the generation mix, from about 60 in 1998, to roughly about 170 in 2018. And you can also see in terms of the diversifications of our renewable energy resources. In terms of the installed capacity, demand, and also generation, again, as far as or as of 2018, you can see which sector actually contributed, or rather, very much, demanded for that from the industry, commercial, domestic, and others. From the energy usage perspective, again, it almost like, I would say, double, from what we have in 1997 as compared to 2017 in terms of, again, our usage. So, of course, as expected, the transportation sector very much consumed, which is from, as you can see, from 13, almost the same value, or rather the same percentage, for the last 20 years. Again, when it comes to the smart grid, I think a lot of people most probably, just wondering, whether, because there's a lot of, I would say, keywords that has been coined with regards to the smart grid. So regardless, whatever definitions that we use, whether that is from the IEC, whether that is from EPRI or IEEE, the same principle in terms of the concept of the smart grid, which is about modernizations of the grid infra, from having a conventional like one-way flow into I would say two-way and also multi-stakeholder and so on. And you can see the grid itself is very much highly integrated, and that also actually translated into the opportunity for the flexible, the connected, and also the resilient grid, which is I'm going to cover in my slide later on. So these illustrations or this figure clearly show us I would say this would be the easiest way to understand what is the difference between the conventional and also the smart grid. As you can see before, the smart grid is one way flow from the generations until the customer. But with the implementation of the smart grid, it's going to be two-way, power flow, and also that involve multi-stakeholders interactions. The network itself is very much, integrated, and we can see a lot of elements, from the control, from this IoT, the plug-in hybrid car, and so on. That actually contributed, as a whole grid. So this is what you can see, from the perspective of the smart grid, whereby you can have so many players involved, converting from the traditional one-directional into a fully interconnected network. So we are talking not just on the solar or not just on the hydro, but as much as possible, whatever the potential resources can also be integrated into the grid network. And also we can even thinking of having the battery energy storage, for example, that also can be used to help especially shade whatever during the emergency or as the storage for excessive energy. So these are all the smart grid elements. Talking about the elements, so we can see a lot of opportunities in terms of contributing either from the GSO or from the utility, and also from the researcher. You can have in terms of the operation, you can have in terms of generation, transmission, distributions, and in fact we also as a customer have the opportunity to play our role which is again I'm going to cover in the next slide later on. So this is rather like multi layer, and also is multi stakeholders involved as a whole that contributed to the smart grid. And again, because I think the idea of the smart grid itself has been coined for more than a decade, and we have a lot of resources available. Yeah, of course, we can find a lot, from the internet, for example, from the website that so many textbook, in this case, they're actually focusing on various topic or various elements of the smart grid, from the control, from the storage, from the protections, smart metering, IoT, and so on. As far as the standards and guideline, again, we have very much well known, like IEC, for example, or CGRE, and also the IEEE, which have dedicated themselves to contribute in terms of educating, in terms of sharing the knowledge, sharing the publications, from the what we call, to the public and also to the researcher, and also even from Malaysian perspective, we have our energy commissions that keep publishing on yearly basis, like the National Energy Balance, for example. So it's not new, to the world, but of course, we're going to see what will be the issues, perhaps that hinder, the implementations of the smart grid in some of the countries. And talking about the smart grid, again, one of the most important and critical element, which is the drivers. So again, so this is well published in the IEC roadmap. We can see the OECD countries, for example, the Organization for Economic Cooperation and Development. So they have, different key drivers that actually drive, the smart grid. So basically, it's very dynamic and changes rapidly, accordingly, with the emerging economies playing, the important roles. So for the OECD countries, for example, they are focusing on how to actually achieve the low carbon and also the energy efficiency, as opposed to the OECD, Asian countries, which is focusing much more on the green economic growth agenda. And one thing that we have to actually, I would say, like, to focus ourselves, as a country, is to look to these emerging countries, which is, you can see they're actually focusing very much on the fast growth of the infrastructure. So having said that, in terms of the electricity consumptions, that has been published by the IEA, the attention is very much on the countries like China and also India, for example. And it's quite interesting, why we should actually focus to the emerging countries in terms of, the implementation, also what drive them. So basically, in terms of the consumption, it's very much driven, by the long-term economic growth and also the aspirations of the rapidly growing middle class. And also the high capacity power lines that actually enable the long distance electricity transmissions, especially for, towards the rural area and so on. As opposed to the OECD, you can see the growth is not very much happen because of, it's very well developed and population, is expected to be slow, and if in fact, is going to be decline in some cases, and the GDP growth is also slower than the emerging countries. So that will be like the difference between these two countries as far as we are concerning in terms of, the driver or the factors that actually drive, the smart grid. Challenges, again, of course, again, most of the countries, which is very much on the business cases and also financing issues. EU and North America also, concerning on the regulation. And just like what we are doing at the moment, public awareness is very crucial, it's very important. It's not just, having the technology, but basically the perceptions from the public, for example, from the community, to accept whatever the technology that is going to be introduced. I think I remember last time we had, a big issue with regards to the smart meter, that people thought that having the smart meter installed that actually increasing the bill. So these are actually, we need more engagement to the public. Having the technology alone may not be useful without engaging the public, without educating the public. And again, of course, a common challenge for both advanced and also emerging countries. It comes back to the, I would say, common issue, of course, in terms of the public funds and also tariff incentive at any stage of the smart grid implementations. And likewise for people like me, for example, looking in terms of the aspect of R&D, and also people like Mike, for example, or the power utility looking into the test bed or what can be actually shown, as the demonstration project. I think that will help a lot in terms of educating the public and also the society. So ISGT, which is Innovative Smart Grid Technologies Worldwide. I think what we can see here, there's a lot of technologies being implemented, especially the solar PV, having the tiles, or rather your roof, acting as the solar panel itself. And also, we have, for example, in different countries like Switzerland, now it become commonly, used and also implemented, for any buildings. Jeju, or in South Korea, for example, I think it's very much known as one of among the earliest, countries that actually, demonstrating the test bed, or rather demonstrating the smart grid project. And but again, looking at how much they have spent, which is the project, the whole of the investment, roughly around 25 billion USD that actually stretch until 2030. So again, the area covering about 6,000 household, and we have they have like two separate phases of the implementations. But I think the key idea here is how we can actually put all the relevant technologies and try to actually build up a real case study. It's not just for the public, but I think again for any new technology to be implemented in the country. This is another large-scale demonstration project in Japan. We have different, I would say, like district, that actually implement most probably different what we call technologies. But it's not just on the technologies, but you can see how much and who are actually people that very much on board to make this demonstration project successful. In Austria, for example, again, which is commonly use the solar PV, to I would say to power up the household appliances. In California, for example, how the integrations of the smart grid technology, to actually monitor, how much the usage. But I think another thing is not just now, for this particular implementation, it's not just on the energy, but also they're actually monitoring, how much the waste utilities, that actually utilized by, by the user. So I think this is one of the things, that if you still remember from the previous slide in terms of the elements, so there's a lot of, opportunity, to contribute, as part of the smart grid. In the US, again, in terms of the real-time data, I think this is very, very crucial because, like with the combinations of the communication infrastructure and so on, I think the idea of having the real-time that actually offer the powerful tools to ensure the continuous, I would say, supply or the continuous, like electricity, to the user, and also in looking in terms of the real-time availability of the system. And I think this is part of the again implementations to reduce the downtime. Towards the to the customer. In Netherlands and also in Canada, how the hybrid car or the energy storage of the battery in this case, for example, it's not just used to power up the car, but also can add as the storage. In the case of having the excessive energy that can also be channeled to the car itself. So this is again we are talking about the ongoing implementation in some of the countries. That again for countries like Malaysia, this is something that can also be demonstrated and can be implemented. This again, the Elia, which is the Belgian operator, focusing on the startup company towards the digitalizations I mean, of the, from the energy perspective, they're actually focusing on that. I mean, to nurture the startup company, towards, implementing of the smart grid. And now we come to one of the critical and important aspect of the smart grid, which is the key changes in future grid. I think we are no longer, able to rely, on the conventional systems. I mean, again, the fossil fuel, the tariff, hikes and so on. So there's a lot of, like opportunity, looking into the flexibility, and also connectivity, and last but not least on the resiliency. But of course, this comes with a lot of challenges. For example, if you're talking about the flexibility, when talking about the flexibility, we're talking about, like the generation perspective, for example, how we can, varies, the resources, and also with the uncertainty of the fuel prices and so on. But again, these challenges, it is actually the opportunity that can be translated into a lot of, benefits, towards the enhanced flexibility. For example, then we can think of, how we can minimize the equipment damage. We can actually prolong the lifespan of our equipment and so on, the grid and the cost effective of the system. So all of each components of the flexibility, the connectivity and resiliency comes with challenges, but also comes with the potential, benefits, for those implementer. And one of the key, I would say one of the example, or one of the, I would say, factors, we're talking about the grid interconnections. So these are all the, I would say, the ideal situations, looking how we can, like interconnect the whole grid. I think we do have, one of the power line here, which is the 500 kV that actually connected from Gurun to South Thailand. But looking into the other countries, for example, because we are talking about the future of the power systems. So it's not just, consuming whatever the energy, that has been generated from that particular country. No, we're talking about the cross boundaries, utilizing, how much, the clean energy that they have, and that can also be used as an exchange, in terms of, the benefit. So this is 3 days ago, which is 13 July, that comes to us, as a great news. I mean, as far as the smart grid is concerned, the Viking Link, which is about 765 kilometer, connecting via the underwater cable, will connect the UK and also to Denmark in order to access the clean energy produced by the wind, generations. So the cost of the project itself, roughly about 1.8 billion pounds sterling, and it now actually kick off, and is going to be, or rather tentatively to be completed in 2023. So this is, I think, the great, what we call the, I mean, one of the, perhaps, one of the best demonstrations of these great interconnections. We're not talking about the, the neighboring countries, but we're talking about much more, distance, as far as the, the country is concerned. So it's really great opportunity. Of course, massive in terms of the implementations, the challenges and the complexity and so on. Second thing is on the integration of the RE, sources. So we're talking about having, it's not just, again, the solar or just like the wind power, for example, but we're talking about how we can, totally integrate the systems, or rather the whole systems, into one source of energy generation in that case. So again, it's going to be challenging from the aspect of the implementations, and also aspect of the regulation and the standards, the fact that the standard that needs to be developed, of course, on that basis. But again, we're talking about the key futures or the key challenges, and that is going to happen. And talking about the energy storage, again, of course, if you can still remember, I mean, in the old days, how much, the cost to actually install per kilowatt of our solar PV systems. So likewise in this is, of course, is quite new in terms of the technology, and of course it comes with slightly high price. But again, as we are moving forwards with a lot of like I would say opportunity and also technologies that's going to develop with regards to the energy storage, then I think the price will definitely or will surely go down, and then you start to see how we can actually see the energy storage finally can come into the grid and can be part of the grid. It's not just to shed the like the electricity. I mean say for example during the high tariff or during the during the what we call the on peak, but also during the peak hours, but also I mean we can even like use the energy storage as a what you call standalone, or rather to be the off grid for our household itself. Demand response management. The regulations, the frequency is going to be regulated through the short-term balancing of supply and also demand. We can see the communications will happen, between the customer, and also between the control center, between the grid operator and so on. And also we're going to see in terms of the EV charging infrastructure. And we have seen that, but it's not as what we actually expected in terms of the future. I think nowadays we are talking about the data, which is much more valuable in that sense. Availability of the data can be key, to the development of the new technology. Can also be a key, in terms of the business opportunity, how we can utilize the data. And as we can see that in the era of the, we can see Internet of everything. It's not just the energy, it's not just Internet of things, Internet of people, services, and so on. So you can see how much the value of the data, because with the data you can start to think in terms of like artificial intelligence, deep learning, and whatever the technology that you can call it, with the availability of the data. You can even forecast what happens to your system performance and so on. And now we're talking about the new business model. Of course, industry like ABB, Siemens, for example, very much looking towards that. And in fact, we have also, the grid operator in, I think, one of the country in Europe that also start to look into this kind of model, like having the, the grid, but in terms of, they have different, IPP that utilizing the, their infra in that case. So likewise in this case, so we have to think in the new business opportunity, just like all these companies actually doing, are doing at the moment. Again, of course, some of the people have seen this slide during my first presentation, I think like a couple of weeks ago. We're talking about the energy trilemma in that case, in terms of the energy security, environmental sustainability, and also energy equity in that case. So this is very well highlighted by the energy commissions in their website. So what will be the goal for the energy security? Of course, in terms of reliability, efficiency, quality, just to make sure that whatever that we supply to meet the demand, and also the quality of the electricity itself. Environmental sustainability, looking into how we can actually deal with the decarbonizations. I think that will be the keyword of the electricity and also the gas supply chain. And the energy equity, which is how we can achieve like cost effective of the system from the producer perspective and also from the consumer perspective in that sense. So that will be the target that put forward for us as a country, and we have pledged that. As far as the utility, or in our case TMB, for example, I think for the last most probably like 6 years or 7 years, you can see in terms of the SID, which is the interruption per customer per year, very much reduced. I think that's what they have actually targeted in this case. So I think that will be a good sign for us in terms of how we actually justify and how we actually evaluate the quality of the energy and also the quality of the electricity that actually we are getting from the provider. Okay, now where are we? As a country in terms of as far as the smart grid is concerned. 25th of July 2018, we can see there is a publication published by the Energy Watch. How much the TMB actually invested towards, or rather to achieve the grid of the future in this case. And I think having the smart grid demonstration project in Malacca, for example, that will be like a good sign for us to again come out as what happening in Jeju or in Japan, for example, so that people can see the real implementation, the real case study, and we as a researcher, for example, can take that opportunity, I mean, to even learn and to even implement, whatever the technique, whatever the AI, you name it, to the system. And we can see the operational phases, from phase 1, 2010 until 2015, very much on the efficiency and reduction of the CO2. And I think now with a strong support from UNIDO and also MITE, and that will be a great opportunity for us to see, I mean, the re-implementation, sometime, hopefully, by this year. Again, as I mentioned, even during my first presentation last time, that at least what we have been involved, and at least from the perspective of the TMB, what they're actually doing, I mean, with feed-in tariff, for example, last time by SEDA, and also 2017, the net energy metering, and now we're having the LSS, which is the large-scale solar, digital substation automations, DLR, for example, the dynamic line rating, which is, I think, they will be a good implementation, whereby now we are thinking of, or rather concerning the, how much we can actually increase the capacity of our current infra in that sense. So how we can actually, because from, sometimes, or rather previously when you design the system, sometimes based on, like I would say the static, parameters and so on. Now, with the influence of the real-time informations that we can get, especially from, different resources, MET department and so on, how we can actually see the real performance of the system, so that there will be, like an opportunity, from the generation perspective to reduce the stress from the generation side, and also from, the operational of the grid, that in terms of avoiding any, loss to the load. The automatic fault analyzer, I think, again, this is currently ongoing, with TMB as well, how, I think if you have a very good idea in terms of recognizing what will be the faults, I think then it gives us, much better idea in terms of how we can correct or how we can actually mitigate, the problem that we have. So GIS is again another opportunity, and I think this is very interesting because I think now it is started, to be looked by different, utility and also countries. How you can actually utilize the geographical informations, mapping your asset, into the system, so that you can have all the historical informations. You can even forecast what is going to happen, to your grid or to your asset. So this is very much, interesting kind of implementation. But of course, also at the research, level as well, there's a lot of opportunity, there's a lot of things that can be done. Way forward, last sections of the presentations. I think looking into the whatever that we put as a target to achieve, I think it should have, multidisciplinary approach in that sense, So you need to have, different people with different expertise, different levels, different, I would say, roles in that sense. For example, you're talking about researcher, we're talking about the utility people, we're talking about the regulator, for example. So they are all need to place their role in that sense, how to actually achieve things holistically, as a team, or rather as a complete, project. Strategy agenda in this case, I think we have seen, of course, it should be clear from the national perspective, that in terms of the visions, and also it should come out as a nice roadmap, that to be implemented, that comes most probably in much more solid phases, and also the agenda to be achieved, at least, stage by stage, for certain period of time. Second thing, on the stakeholder support and roles, again, having the technology alone, is not really, helpful in that sense, without support, a strong support from the ministry, for example, relevant ministry, and also support from the, like local industry, local player, and so on. That's bad. I think this is very interesting because we're going to see this later on, that is going to be implemented, hopefully. As much as we're talking about the smart grid, I think another aspect, which is we need to also train our people in terms of human capital development in that sense. So I think we cannot, like always rely to the technology, of course, to the outsiders. because at the moment, I think, yes, we can accept that, okay, whatever the technology, like contributed by the foreigners or by the outsiders, and that also comes with the expertise. But I think as we are moving forward to have our own solid, smart grid agenda, that we need to have our own people. We need to train our own people. We're talking about the regulator, we're talking about the utility, we're talking about the researcher, the students, and so on. So I think that to me that will be like a way of judging things, whether that is successful or not. RD, CI, and also E, which is, I think, as we are moving forward, we are going to have like a local talent. We're going to have the local industry, to be part of the smart grid, implementation, or rather smart grid agenda. Then you start to see most probably the contribution of the new knowledge in terms of coming out with the new devices, new equipment, and so on. And from the researcher perspective, like focusing on different aspects of the smart grid itself. And then we are talking about the commercializations, we're talking about the innovations, and finally, I think we are more than happy to see, as many as our people, finally being the entrepreneur. So in that case, having from the scratch, into a successful entrepreneur. I mean, we can also develop as a program in that case. And last but not least, in terms of the policy and regulation, I think this is very crucial role that needs to be played by the relevant, like ministry or regulators, for example, like Energy Commission, SEDA, and also MOSTI, and also this what we call the energy-related ministry. Modernizing power system of the future. We're talking about the resilient, flexible, and connected grid. There are things that we need to judge in this case. For example, like we have how we going to deal in terms of resiliency. For example, having like high frequency. High frequency means frequent event, or we call it. So high frequency, high impact, or low frequency, high impact, or low frequency and low impact. So how are we going to deal with that? And we're talking about the flexibility of the system. With so many uncertainties, how are we going to deal with that? I mean, the power market, we're going to about few prices, the diversifications of the generations, regulation and policy. And on the perspective of the connectivity, now we're talking about the, moving from the conventional one-way flow of the electricity generation into two-way flow. So how are we going to deal with that? How are we going to modernize the grid? Now we're talking about the upgrading of the systems. Shall we refurbish of the grid infra, or shall we operating, increase the the rating, or shall we upgrading the system? So all the judgment that needs to be done wisely in that sense as we are moving forward. And also having the sensors, for example, with so many like new technologies available on the market. I think again we need to judge in terms of we need to judge in terms of whether that is technically viable or financially viable. So we need to, before we can actually, go and also focus on a certain, aspect of the implementation. I think this is very crucial, and it's very well established, very well explained by EPRI in the US. I think this would be a good, source of informations, for us. The smart electrifications, which is the key to energy efficiency. So this is going to be the future of the power system, highly integrated with so many, generations, large-scale network that we have seen, earlier, how the grid interconnected, that cross-boundary between the countries and so on. So this is going to be, again, a way forward. This is going to be things that we need to, think along that line. As far as for us as the customer, for example, I think we would like to see, like in the future or in the next couple of years, like this is going to be the future home, for us, having all the, offline, online, informations. We can even access, remotely all the, appliances. We can even see, how much the energy, that's been generated, how much we consume, and, how much we invested, say, for example, the solar PV, what would be the ROI and all those things. So